Thank you very much for attending today our webinar. Today we're going to talk about automated manufacturing of CAR NK cells. I will go over an overview of CAR NK cells, how the field is trying to enhance the cell cytotoxicity of CAR NK cells, and I think we'll spend most of the time in this CAR NK cell workflow. I will show you the tools from research to clinical manufacturing of CAR NK cells. We just finished with some remarks. So let's start. I hope you're ready. I just want to introduce really quickly Miltenyi Biotec and the role in this cellular therapy. So our mission has really been for the past 30 years to advance the scientific research and medicine by providing solutions, of course, to make sure that the cell and gene therapy in the biomedical research is also pushed. And this is pretty much summarized in this slide. Since 1989, Stefan Miltenyi had his vision, and we have been providing you with more than 15,000 products that have been already published in more than 20,000 scientific publications, enabling more than 55,000 cellular therapy procedures. So for this, more than 2,500 patients have been treated using our technologies. So this is in the field of stem cell transplantation, also in the treatment of virus or using disease or T cells, and a couple of other different cell products. So therefore, you can see that we have at least 3 decades of experience in this cellular therapy, and we're fully dedicated to help you to further expand your clinical applications. So today the focus will be on NK cells. If you are an NK cell expert, then you can take a little nap. If not, just have a quick look at this slide. So NK cells are part of the innate immune system, and they played a major role in the rejection of tumors and virally infected cells. And what is important is that they can kill these target NK cells in a contact-dependent manner that is a non-phagocytosis process, and this is the most important part, that they do not require this prior sensitization to an antigen like the T cells. So they're the first line of defense pretty much. And how are NK cells able to kill? NK cells can kill through direct lysis of target cells by secreting perforin and granzyme B, so causing necrosis and apoptosis. They are also really good secreting cytokines like interferon gamma or TNF alpha. They also induce apoptosis of the target cells by expressing these death receptors like Fas ligand, and they also perform this antibody-dependent cell-mediated cytotoxicity. This means expressing CD16 that recognizes the Fc part of antibodies that are already bound to target cells. And this is a major mechanism of the normal therapeutic antibodies that we see. So how can we use this in the actual clinic? Well, because of NK cells are really good at not providing graft versus host disease, we'll talk a little bit about that later. You can normally get NK cells from healthy donors, you isolate them, you can expand them, and then infuse them into cancer. And I'll show you a little bit of what has been done with this NK cell therapy. Let's go into the field of the CAR NK cells. So for the CAR NK cells, as also with other type of cells, there are different technologies in order to introduce these different genes. One can do viral gene transfer or non-viral gene transfer. In the case of NK cells, here I'm just giving you some references regarding gamma retrovirus, lentivirus, alpha retrovirus, some studies doing electroporation or using the sleeping beauty transposon system or even phagocytosis. So these publications are using NK cells, and they are aiming to use this different gene transfer method. So how can we use then the CAR NK cells in the therapy? Again, because we can use healthy donors, we will do the genetically modification outside, so ex vivo. We can expand them and then infuse them to cancer patients. And what is really important that I mentioned twice already is the use of allogenic NK cells. In comparison with CAR T cells, there are many different advantages compared with NK cells. So for example, CAR NK cells will have a natural killing instinct, so they have different mechanisms of actions. Like I mentioned before, ADCC, they secrete cytokines and they secrete granules, and they can induce apoptosis, recognizing other receptors that are not just the specific target. Most importantly, they do not cause graft versus host disease. NK cells are able to balance very well the killing of target cells by the overexpression of these activating receptors in the target cells. Therefore, they can recognize malignant cells better. We can get NK cells from so many different sources. For example, generate them from iPSCs, from cord blood, from peripheral blood, and even now some studies are using cell lines. Another advantage that could be good or bad, it's the relatively limited lifespan of the NK cells, so they really have a short-term persistence. In this case, it can be good. Let's say that we have a target that is also expressing healthy NK cells. Then you might want to just infuse NK cells, they do the job, and then they'll be gone in 2 or 3 weeks. In the case that there are some remaining malignant cells, then the problems will arise and we would have like a relapse. But because these cells are allogenic, you can probably think of another infusion of CAR NK cells. And again, CAR NK cells, they retain their intrinsic cytotoxicity because they have many different receptors, and the promise of this off-the-shelf cellular product is becoming more real actually. We can use, for example, these cell lines, iPSC, or different cell lines that could be used as a bank of CAR NK cells and can be easily available for patients. So this is a big table. Don't worry, you don't have to focus on everything at the same time. The first thing that I want to show you is the amount of participants that are recruited for these phase 1 clinical trials. It's normally no more than 30, so 20, 10, 10. That's why the amount of patients that are now being treated with CAR NK cells is quite small. But I am very optimistic. One of the things that I want to highlight in this slide is that the majority of the studies are being conducted in China, in the US, or there's one also here in Germany. There are probably more, but not all of them are registered under this clinicaltrials.gov. The other thing that I wanted to also highlight is what type of indications they are being used for CAR NK cells. So apart from hematological diseases, we also have some solid tumors, glioblastoma, hepatocellular carcinoma, and even pancreatic cancer. So this is a little bit different from the current CAR T cells. They have been used mainly in these hematological diseases, and I hope with these more than 43 NK and NKT CAR preclinical studies, we will actually advance and have more of these CAR NK cells used not only for hematological but also for solid tumors. Okay, now let's continue with the strategies to enhance CAR NK cell cytotoxicity. Here I just want to give you a brief overview of what are the normal constructs, the CAR constructs that have been used in the field. The T cells have been taking the lead in this field, so they have a couple of years of advantage, and they are the ones that started with the first, second, and continue with the third and fourth generation of CARs. I have to say that I guess for the ease of convenience, most of the studies using CAR NK cells have just adapted these third or fourth generation CARs and use it for NK cells. Just give you a couple of examples. One of them is the one used by this publication, so it's in the MD Anderson, and what they're doing is using this fourth generation. They have also learned from the experience of the T cells, so they have inserted a suicide gene, they have their target, their co-stimulatory, and also interleukin-15 to make NK cells persist. So this publication here shows very nice that this is a nice construct that you can get really nice response. Another one that is also very interesting is a publication by Dan Kaufman, so Lee. They're done in California, and what they've been doing is to explore the different signaling pathways that could be better for NK cells. So we know that, of course, DAP10, DAP12, and 2B4, so different costimulatory molecules, are essential for the NK cell activation. So in this study, they show the different combination of CARs, and they study how well they acted. In this case, they found out that this CAR, the CAR4, using 2B4 and NKG2D, is the best combination, and they demonstrated better anti-tumor activity. So this is just an example of how in the future CAR-NK cells might be different from the CAR T cells constructions, and it makes sense because CAR-NK cells are different cell subtypes and have different ways of being activated. So let's continue now. We'll spend a little bit more time on this CAR-NK cell workflow. If you are already thinking about translating your research into the clinic, I would like to briefly introduce our platform. So we have our CliniMACS Prodigy. This is an instrument that enables you to prepare cells, to separate, to activate, to modify them, to culture, and also to have your final formulation in a one automated and controlled closed system with single tube use that you can just have every time that you do a procedure. If you're not familiar with the system, you should definitely contact your local support team, and I'm sure you will find more information. This is a really nice instrument. It allows you to perform in a flexible way the manufacturing of your cells. You can control the transduction, your shaking conditions, when to feed, and what to put as final formulations. They are already performed at a specific time, so whenever you tell them, let's say at day 3, I want to exchange the media, it will happen automatically. At any time, you have access to your sample, so you can do QC, and there's also an integrated camera that allows photos to be taken. So now that I show you just a little bit about the CliniMACS Prodigy, how would it look like for NK cells and these CAR-NK cells? So it's something like this. In the case of NK cells, we need to have 2 different tubing sets. One of them in which we do the CD3 depletion, then we transfer the final product to the next tubing set to do a CD56 enrichment using the 520. In this tubing set, we are able to do the NK cell activation, transduction, and the cultivation using our cytokines, our medium, and our vectorfusin. So everything that you need. After that, you can harvest in your final formulation, and we are also developing all the tools for your IPC-QC. So to find out if there are any contaminants, how efficient was your transduction, how good your cells are, and also some panels for research. Everything using our Max Quant, and also automating this into Max Express modes. So I want to show you, because everybody has to start their protocols and research after then you translate to this manufacturing. I want to show you step-by-step generation of CAR-NK cells in vitro. From the research side also to making this everything in one system, like I showed you before, in our natural killer cell engineering process that will be coming soon. So let's start with the first part, the cell separation. We have many ways of separating NK cells from different products. If you have as a sample of blood, you probably normally perform separation using FICOs or density gradient to obtain PBMCs, and then you can either use microbits or positive selection or isolation kits to make sure that you have untouched cells. In other cases, you might start with buffycoats or other type of whole blood, for example, and in this case you can also use straight from microbits, or if you want untouched NK cells, are Max Express. In the case that you are really into the steps in which you want to translate your protocol to the clinic, I will always recommend to start thinking translational from the beginning. So the way that we will isolate NK cells in the clinic is via a CD3 depletion followed by a CD56 enrichment. So we have available these microbits that you can use either from PBMCs, or if you have buffycoats or blood, you can also use our straight from technology. So it's just a hint for you that if you want to have exactly the same, you probably want to use these two microbeads. And this is how it looks when we use our Prodigy system. I mentioned to you that we're using two different tubing sets. So we start with the CD3 depletion, autoleukapheresis product, get CD3 depleted, T cells are removed, and the NK cells and monocytes and other cells are remaining. After that, we perform a CD56 enrichment, leaving us with a very pure fraction of NK cells. And this is already in our tubing set, and is our starting material to perform our CAR NK cells. So for the next step, for NK cells, we need to activate them, then deliver the gene and expand them. NK cells have been quite famous, notably famous in the field, because they really don't like to be proliferated. They get really exhausted when they proliferate, and normally we find that after expansion, they do not retain this cytotoxicity. So these are two main challenges that the field has had. I'm actually quite happy to just introduce, if you haven't seen or used our medium, our NK-MAX medium. We really developed this media specifically for the NK cell activation and expansion. We have tested it against different competitors, and we have proved that we have a superior NK cell expansion. It is such a nice media because it has no animal components, no proteins, actually no insulin, no albumin. It remains, makes the optimal growth and high expansion rates of the NK cells without the expansion of the T, the D, or the B cells. And most importantly, you can do everything or your standardizations on research grade, and you have exactly the same formula in GMP. So it is quite useful. I'll show you just some data showing the expansion of NK cells. So using our TexMAX as our T-cell media or other competitors, you can see that using NK-MAX media, you get at least 5-fold more NK cells compared to other media. This is very nice. You also have to take into account that there's a lot of donor-to-donor variation. So I think it's not only us, but you probably also observe in your samples. This is an example using NK cells as a starting material. In the next slide, I'll just show as a starting material PBMCs. So if you expand from PBMCs using a combination of interleukin-2 and interleukin-15, you can get really high expansion rates. And this is comparing our research use with our GMP. So they're very similar. And most importantly, if you perform a killing assay using K562 cell line, after 14 days of expansion, you can see that you have really nice killing. NK cells are not exhausted, and they're able to kill target cells. So this is an example of using research in the GMP grade on a manual setting. And in the next slide, I want to show you how it looks like when you use our Prodigy system. This is only activation and expansion. And if you start with this is an example of 3 donors, you will get from around half of 1 times 10 to the 7 or 10 times 10 to the 7 cells. You can go to all the way to 2 times 10 to the 9 NK cells. This is again 14 days with a very pure product and using only cytokines. So this is a feeder cell-free system. We're not using any cells apart from the NK cells in the system. Okay, this is only if you want just to expand. I'll show you some data now regarding the expansion, but also including the transduction. First, I ask a customer to test their system compared to us. So this is data from a customer. I gave her our NK-MAX media, our cytokines, and also our vectorfusin, and I asked her to do expansion of NK cells compared to their own system. So in her own system, you can see that either transduced or non-transduced, NK cells are able to grow, but to a less extent compared to using our system. So untransduced, you got around 70-fold expansion compared to 53, but this is the most striking one. So using our system, you get around 61-fold expansion compared to 35 using the other system. This is almost double the amount, which is very important for you. Every cell will count at the end. And let me tell you a little bit more about the transduction. So most of you mentioned that you have challenges with this gene transfer delivery. At the end, I would just show you a small publication that we have regarding these vectors used for the NK cells. But for now, I want to present to you our tools to enhance this gene transfer. We have developed vectorfusin. It was initially developed for the T cells, but it works really nice with the NK cells. This is used for viral transduction enhancement for static and also spinaculations. It enhances the lentiviral and retroviral transduction, is fully synthetic, non-toxic and soluble peptide. It is really easy to use. You only need to mix your vectorfusin with your cells, and then after that you just have to do a wash and that's it. There's no need to pre-treatment or no need to pre-coding compared to other systems. And most importantly, you do it on your research setting and easily you can just transfer to the GMP. And I want to show you some data. So I mentioned before that you can use cell lines like NK92 or primary NK cells for CARs. So in this case, this is our non-transduced sample using only the vector. So we have around 21 or 17%. And then using vectorfusin. And you can see the really increase in the efficiency up to 88 or 85% now are CAR NK cell positives with the help of vectorfusin. So this is something that will depend on your vector. You will have to test it yourself, but I really encourage you to give it a try because it could be that you also see this amazing enhancement. Going back to the customer data that I had, here she didn't see a difference in between the CAR transduction, but most importantly, she saw, like I mentioned before, double the amounts of CAR NK cells used in our system. So the combination of vectorfusin or max media and our cytokines can give you 2 times the amount of CAR NK cells compared to other conventional methods. So make sure that you give it a try. One thing that I want to highlight is that there is a lot of donor-to-donor variability. So please don't be disappointed if you test one donor and you get really few NK cells. It could be that it is your donor. Try another donor, minimum 3. You will see that there's a lot of this donor-to-donor variability using NK cells. And finally, I want to show you how it looks like using the Prodigy. So we start with around 10 times 10 to the 7 NK cells. In the first week, NK cells are not disturbed, so we just change some media. And at day 7, this is our protocol, we perform the transduction of CAR NK cells. In this case, you can observe that around 30% of those were positive for CAR NK cells. We follow them and grow them until day 14 to get around 1 times 10 to the 9 NK cells, which half of them, a little bit more, are CAR NK cells. And just in this point, I want to remind you that infusion of CAR NK cells plus non-CAR NK cells is actually good because I told you in the beginning that CAR NK cells are able to recognize a specific, but NK cells have also their innate receptors, naive receptors that recognize CAR cells, and they can also kill. Okay, so I will continue with the last part. So once you have performed and produced your CAR NK cells, you probably want to verify if they're working or not. So there are a couple of ways of doing this. Most commonly for CAR NK cells, you will have an assay to detect cytokines and also a killing assay. And today I want to show you just very briefly our tools for this. This is how we do it. We have developed a MaxPlex cytotoxicity T and NK cell kit. This means that you can detect 12 different soluble molecules, including the most important for killing, granzyme B, perforin, or cytokines like interferon gamma from one of your sample using our MaxQuant technology together with MaxPlex. It's really efficient and it's really convenient because you get your supernatant, you can freeze it, then once you have enough samples you do your plate and you have so much information regarding all these cytokines. Now for the killing assay, you can also use our MaxQuant. Typically you can label your target cells with a dye and then you culture them with the NK cells. In this case, we have an example here of non-transduced NK cells and our CAR NK cells. And you see that as you increase the effector to target cells, you eliminate more of these target cells. Up to 5,000 counts are left off here with untransduced, but with CAR NK cells, we're able to almost eliminate all the target cells. So this is an assay that has been done previously in many other publications using different dyes, and you can also do this using our reagents. So of course, once you finish your cell product, you not only have to do your multi-parameter analysis, you probably have to do quite a lot of QC, like qPCR for your vector, or other safety testing that is done mainly by other labs. Just here I want to highlight that for this multi-parameter analysis, we have absolutely everything you need. So we have panels for this cellular composition. We will also release panels to make sure that you know the potency of your CAR NK cells and also to know the impurities. We already have available one of those. It's like as a special protocol, looks like a very detailed SOP of how to do the gatings, which antibodies to use, and it's everything there for you. So feel free to request this in case you're interested. And to finalize, I want to give you just a snapshot. This was a movie, but it's really hard to show movies. Just in general, here we just have the action of CAR NK cells. In green, you have the tumor cells. So if it's the target cells only, of course, they reproduce and they're growing. If you put some NK cells that are non-transduced, there's a little bit of killing, but not so much. This is a cell line that is resistant to NK cell killing. And if you infuse CAR NK cells, then you will see very nice killing, some remaining tumor cells, but NK cells are able to kill very good. Okay, so I'm finally almost done, and I would like to finish and thank you